Right now, in this question, the pulley is smooth and massless. You can see a fixed pulley, and the string has a total mass of 5 gram. Now there is a string with mass, just like previous question. And the two suspended blocks, their masses are given respectively 25 gram and 15 gram. The system is released from the state where L equal to 0. So which means that block A is initially very close to the pulley, and the entire length of the rope is hanging on the other side like that. And then because the heavier mass is on the left side, that is 25 gram is more than the total mass on the right side, which will be 15 gram plus mass of the rope. Mass of the rope is 5 gram. So A will start moving down. Eventually block B will come very close to the pulley and just about to hit the pulley, where L dash becomes 0. And during this process, the acceleration of block A will be 4 options are there. So obviously, just like the previous question, it is not going to be a constant. So we will find out what will be acceleration of the block A in this process, how it will vary. So initially block A is here, and finally block A is going to reach where block B is going to just about to hit the pulley. So in this process, we will figure out how its acceleration is going to change. So at some particular instant, you look at this particular diagram. I'm assuming that the part of the rope on the left that has m2 gram and part of the rope on the right has m1 gram. Since the pulley mass, or sorry, pulley dimensions are neglected, very small size, so we can ignore this much length of the rope. So we can treat as if there is a negligible mass present on the pulley for the rope. And we can write acceleration. So 25 gram this side will be accelerating down, 15 gram will accelerate up, and this expression for acceleration, that will be total. When you have a fixed pulley, we can write it as total mass on the heavier side minus total mass on the lighter side divided by total mass into G. So that is again a pulley part, where we can write acceleration equal to 25 gram. So I'm substituting masses in gram now, because it is ratio anyway, it doesn't matter. So 25 gram plus m2 minus 15 plus m1 divided by total mass will be 25 plus 15 plus m1 plus m2 is anyway going to be 5 gram. This whole multiplied with G, that will be the acceleration. So at the initial moment, m2 will be 0 and m1 will be 5 initially, that is. So you find the initial acceleration, let's call that a1. So you substitute, it will become 25 minus 20 numerator. So 25 minus 20, that is 5, divided by denominator is going to be 45 into G. So this is going to be 1 by 9 into G, that is initial acceleration. And finally, when B is just about to go and hit the pulley, then M1 will become 0 and M2 will become 5. And at that moment, the acceleration will become, so 25 plus 5, that will be 30. 30 minus 15 will be 15. So 15 divided by 45 into G, that will be 1 by 3 into G. So A2 is going to be 3 times A1. So acceleration is increasing by a factor of 3. So if you look at the options, C is going to be the correct answer for this particular question. And note that the blocks, when they are moving, the blocks A and B, they will continuously have acceleration which will keep on varying. So if there is a question where you're asked to find distance traveled or displacement, something on those lines, you should not use equations of motion. Just keep that at the back of your mind, because the string, if it has mass, then acceleration of the two blocks, that would keep on varying for different lengths of the string on either side of the pulley. Okay, so that's about this particular question here.